Is my screen is visible, ma'am? Hello. Can you please confirm?
Yes, good evening, sir. It's visible, sir.
Okay, ma'am. Thank you. Ma'am, let us start actually. It's already time has crossed.
Sure, sir, sure.
Okay, ma'am. This is week 10. Okay. Week 10 actually we're going to solve some questions related to the courses. Okay. So here actually mostly this week 10 is related to body plots. Okay. And how the minimum phase system, non-minimum phase system, what the classifications like that. So I have just go through some of the questions. If you have any doubt, please tell me. So before that, actually, let me give an introduction. What is minimum phase system? So in the lecture, it is mentioned actually the minimum phase system means actually a system. You can consider a system which is having no, which is having uh, no right hand side. Okay, right hand side poles and zeros. Okay. So there will be no poles and zeros on the right hand side. Simply you can say how to verify that. If you want to verify that, then what you do, you have to put limit and omega tends to infinity. Okay, and take the angle of the transfer function, and that angle should be poles minus 0 times of minus 90 degree. Okay, so this condition it has to satisfy. So let me give an example on that. Let's give an example. Let's see. Suppose a transfer function is given to you that 10 into s plus 2 divided by s into s plus 1. I can say s square plus s plus 1. So if the transfer function is given like that, then what you do, you just find out the uh, limit omega tends to infinity. When limit omega tends to infinity, I already discussed this on my polar plot class, that omega tends to infinity, how we are going to find out the angle of the total transfer function, and also omega equal to 0, also how you going to find out the transfer function, means angle of the transfer function. So remember that at omega tends to 0, then only whatever the poles and zeros at origin, that will contribute the angle. Let's say, suppose in the question, if I'll ask you find out the angle at omega tends to 0, then what you will do, you just forget about all the terms, just find out how many poles and zeros at origin. So you see here in this transfer function, there is only one pole is exist at origin. Okay, so one pole is the exist, and for one pole you know that the angle contribution is minus 90. So at omega tends to 0, the angle contribution by this transfer function is only 90 degrees. Okay, minus 90 you can say. But at omega tends to infinity, because minimum phase system you have to check by putting omega tends to infinity. So for omega tends to infinity, you have to consider all the effective pole zero angle. Effective pole zero angle means you can say there is one zero is there. So s plus 2. So this zero is located at this location. Okay, this is 0. So at this location 2. Then another, so 1 0 will be cancelled by one pole, because the angle contribution by this 0 is plus 90 and angle contribution by any pole is minus 90. So like that you see that this one zero is there, so that 0 will be cancelled by any of the pole. Let me cancel by any of the poles. So how many poles now effectively it is there? Only 3 poles are there. S plus 1, s square plus s plus 2. So this is second order, so 2 poles will be there. So total now 3 poles are there, and one pole will contribute 90 degrees. So 3 pole will contribute minus 270 degrees. So at limit omega tends to infinity, the total angle of this transfer function is minus 270 degrees. Are you following, ma'am?
Yes, sir. Following, sir. Clear,
Okay,
sir.
ma'am. Okay. So now you can see that.
Understood, sir.
Yeah. So now you see that this angle contribution is how much? Minus 270. Minus 270 means you just now put here P minus J. Total number of poles is 4. So 4 minus 1 into minus 90. So definitely that will be minus 270. So it will be satisfying. So it is a minimum phase system. And by looking at the transfer function, you can say that all the poles or zeros lies on the left hand side of the S plane. That's why it is a minimum phase system. The definition of the minimum phase system is that all the poles and zeros should be lie on the left hand side of the S plane. Similarly, what is a non-minimum phase system? Non-minimum phase system means at least one poles or zeros should be lies on the right hand side. Okay, so basically zeros lies in the right hand side of the S plane is called a non-minimum phase system. Okay, let me give an example of a non-minimum phase system. If I say a non-minimum phase system, so non-minimum phase system means whatever the transfer function, angle of the transfer function at limit omega tends to infinity, that should not satisfy this relation poles minus 0 times of minus 90 deta. It will not satisfy. If it satisfied the minimum phase, it will not satisfy non-minimum phase system. Let me give an example. Let's say um, you take an example. This example is transfer function equal to 10 into s minus 1 divided by s into s plus 2. Now clearly you can see, ma'am, that 1 0 lies on the right hand side at 1. So at this location 1 0 is there. So definitely you can say whenever 1 0, any of the number of 0 lies on the right hand side, there is a non-minimum phase system. Also you can verify by using the angle criteria. Okay. So like that you have to classify that. Suppose one question will be given minimum phase system, non-minimum phase system, then you can identify by looking at the number of poles and zero locations. Okay. So let me go through question number one. So here actually the question is given, consider a system with closed loop transfer function. Let me check actually whether I started the recording or not. Yeah, started. Okay, so this is the question number one. In the question number one, actually just looks at the question clearly. What is the question is saying? This is a closed loop transfer function is given. Closed loop transfer function is given s minus alpha square divided by s cube plus 6s square plus 11s plus 6. Okay, now he is saying that for alpha greater than 0, alpha is greater than 0 is given. Alpha is greater than 0 means you can say that alpha is positive. Alpha is positive means s minus alpha term should be lies on the left hand side or should be lies on the right hand side. S minus alpha is positive, so s minus alpha equal to 0, so s equal to positive so number. It means it has to be lies on the right hand side. Let's say some point at 0, this alpha is lies on the right hand side. So this is the definition. For alpha greater than 0, the system is a what, minimum phase system or non-minimum phase system? Because 1 0 is lies on the right hand side, because alpha is positive, you know
So
that.
non-minimum.
Yeah, so it is a non-minimum phase system. Because why? Because 1 0 is lies on the right hand side. As 1 0 lies on the right hand,
Yes,
yeah, as 1 0 is lies on the right hand side, you can say it is a non-minimum phase system. Then it's in the what is an all pass system. So here actually you know minimum phase system, you know non-minimum phase system. Then what is the meaning of this all pass system, ma'am? Have any idea what is all pass system? Remember that in the all pass system, it has unity gain. The gain should be unity at all the frequencies. You know, all pass filter. All pass filter means it has the gain unity at whatever the frequency considered from omega minus infinity to omega plus infinity. You find out the magnitude. This magnitude is always equal to 1. Let me give an example. Suppose the transfer function is given 1 minus s divided by 1 plus s. So what you do, you first find out the magnitude of this transfer function. What is the magnitude of this transfer function? Transfer function 1 minus j omega divided by 1 plus j omega. Take the magnitude of this. Magnitude of this means 1 plus minus omega square root divided by 1 plus omega square root. So both are same. So 1 plus omega square divided by 1 plus omega square. So cancel out. So magnitude will be 1. So as the magnitude is 1, whatever the omega you put at every omega, it has a unity gain. So it is called a all pass system. You understood, my man? What does it mean by all pass system?
yes, yes, sir. Clear, sir. Clear.
Okay. Now, suppose that I am giving another example of a all pass system. The all pass system, let's see the transfer function is given s square minus s plus 1 divided by s square plus s plus 1. you put any omega value. Omega means you have to put any s value. For any s value, the magnitude is always 1. Okay, you put s equal to 0, this s 0 0 cancel, so numerator by denominator is 1. If you put 2 also, 2 square minus 2, 2 square plus 2, and if you take the magnitude, then always you get the magnitude equal to 1. So it is at all the frequency, if the magnitude will be 1, then it is a all pass system. Someone wants to join, let me add. So these are the definition of the minimum phase system, non-minimum phase system, and all pass system. So all pass system, what do you are? All pass system means at every frequency the magnitude has to be 1. So even a question will come in the examination to verify that whether it is all pass system or not, you just take the magnitude and find out the magnitude by putting different values of omega and see that whether the magnitude is coming 1 or not. Okay. Next, go to the question number 2. So what is question number 2 is saying, when a unit step input is applied, how many zero crossing occur in the system response if alpha greater than 0? So what is that transfer function is given? Let me write down the transfer function again here. Okay, so the transfer function is given y of s divided by r of s equal to s minus alpha square divided by s cube plus 6s square plus 11s plus 6. The transfer function is given, and he is always saying that alpha is greater than 0. Alpha is greater than 0 means alpha is positive. It means this alpha should be lie on the right hand side of the S plane. Okay. Now we read the question. How many poles will be lie on the right hand side? Because s minus alpha square is there, so it means multiple poles will be exist at this location alpha. So there are two poles on the right hand side. Okay, now read the question. When a unit step input is applied, now unit step means r of s equal to 1 by s, because unit step is applied, so r of s is 1 by s. Now he's saying that how many zero crossing occur in the system. Zero crossing means how many times if you find out any system, because this is a third order system, if you find out the system response, then the system response is having some graph. Okay, it will cross the zero crossing. Zero crossing means if suppose some curve is there, it will cross the zero crossing at this point because it is crossing the x-axis. Also at this point it is crossing the x-axis. So he is saying that how many zero crossing occur in the system response. Remember that this is already described in the classes, okay, but still you just remember that I'm just summarizing it, that how many number of poles, sorry, how many number of zeros lies on the right hand side. Okay, so as many number of zeros lies on the right hand side, so that many number of zero crossing occur in the system response if it is a unit step is applied. So it means how many number of zeros that exist on the right hand side. So two zeros are there, two zeros are there on the right hand side. Okay, so it means two number of zero crossing will occur. So number of zero crossing, the number of zero crossing will be 2. Okay, so answer for this question is 2. Okay, now coming to the question number 3. Now read this question, the same question. Okay, y of s by r of s is s minus alpha square divided by s cube plus 6s square plus 11s plus 6. Okay, same question, but the same question now he's saying that previously he's saying that alpha greater than 0. Okay, now he's saying that take a positive value of alpha. Now he's saying that take alpha equal to 2. Now I'm assuming that may alpha equal to 2 here. Now the question is that at what time, पूछ रहा है, at what time does the dodge the through overshoot occurs in the step system response. Okay, now first of all in the system step response. Okay, so now you'll find out that undershoot. So what is that undershoot point? We have to find out that undershoot point. So let me add someone. Okay, now try to understand what he's saying, that you know that some because two number of poles are exist on the right hand side, so there will be two zero crossing. Okay, let's see this are two zero crossings occur. Okay, like that. Now in this two zero crossing there is an undershoot. You can see clearly that this point is a value point. Value means it is a undershoot point. Okay, overshoot means it is going over to that value step response. Now if I'm assuming that my step response is this line, then it is going below the step line, so this is called a undershoot. Okay, if this is my one line, this point is going above that line, so it is called a overshoot. Okay, now so there are two zero crossings. Okay, this is 0 decibel line, one means this is 0 decibel line. Okay, so now this is an undershoot point. Now you have to find out that undershoot point means at what value this undershoot will happen. So how you solve that questions? Okay, so first to do what you write on the question here, y of s divided by r of s is given s minus alpha square divided by s cube plus 6x square plus 11s plus 6. Okay, this is the transfer function is given. Now in the transfer function you see the step response is given. Step response means your r of s is now becomes 1. If the r of s is now, put that r of s in this transfer function, so now your y of s become s minus alpha is now how much? 2. So s minus 2 square divided by s cube plus 6s square plus 11s plus 6. Okay, if you factorize it, okay, s cube plus 6s square plus 11s plus 6, this is a very fancy number. Remember that s cube plus 6s square plus 11s plus 6 is a very fancy number. Most of the time question will be based on this. Okay, so it is nothing but if you factorize it, it will give s plus 1, s plus 2 and s plus 3. Okay, the product of these three numbers is nothing but a s cube plus 6s square plus 11s plus 6. So I am writing down just on factorizing this s plus 1, s plus 2 and s plus 3, and r of s is 1 by s. Okay, so I am multiplying here because y of s by r of s this function. If I take multiply r of s, then the r of s will be multiplied here. So now the total response y of s is nothing but this value. Okay, now put r of s equal to 1 by s because unit step response is given. So I am now substituting y of s equal to, just open this, s square minus 4s plus 4 divided by s plus 1, s plus 2 into s plus 3, and this r of s is 1 by s, so I am writing 1 by s. Okay, here. So this is your total y of s now. Okay, now what you do, you have to factorize it. Okay, by using partial fraction you have to write it. How you write down this? Let's say I'm writing this a by s plus b by s plus 1 plus c by s plus 2 and plus d by s plus 3. Okay, so partial fraction you know how to solve it. Okay, so now your task is that you have to find out the coefficient of this coefficient a b c d by equating this numerator to this value. Okay, so what you do, find out this abcd value. So I'm just writing down the answers directly. Okay, otherwise it will be time consuming. It will take hardly 2-3 minutes. Okay, so a equal to 2, b equal to minus 9 by minus 9 by 2, c should be equal to 8, and d should be equal to your minus 25 by 6. These are the values of from the partial fraction. Okay, up to everyone is clear how I did this?
Clear, sir.
Okay, so why I'm doing that? First of all, why I'm doing that, I need to find out the time response because this is a Laplace domain. I want to find out the polynomial equation. That's why y of s, after finding out y of s, I will take the inverse Laplace transformation to find out the time response y of t. Okay, so first of all, put the value of abcd and let's see what is this y of s. Now this y of s becomes, so what is that value? A by s, b by s plus 1, Okay, so A is 2 by 3, 2 by 3s. B by s plus 1, B by is minus 9 by 2 into 1 by s plus 1. What is the value of C? C value is 8, s plus 2. So 8 divided by s plus 2. And D equal to how much? Minus 25 by 6 into 1 by s plus 3. This is your y of s. Now find out y of t. Y of t is nothing but L inverse Laplace inverse of y of s. Now find out that value. So 2 by 3 is, if you take the inverse Laplace transformation, it will be only 2 by 3. Okay. Next, minus 9 by 2, so it will be e to the power minus t. Next, 8 by s plus 2 becomes 8 into e to the power minus 2t, and minus 25 by 6 constant e to the power minus 3t. So this is your y of t. Okay. After finding out the y of t, so what is the question is asking us to find out at what time does through the undershoot occurs. Okay, so you need to find out these two time t1 and t2 value. It means if you have a second order system or any polynomial, if you want to find out at which point the zero crossing occurs, then what you do, you know that for any system, to finding out the value of the zero crossing, you have to differentiate with respect to time and make it equal to 0. So why? Because these two values satisfy this equation. So t1 and t2 satisfy this equation, means t1 and t2 are nothing but the root of the equation. To find out the root of any equation, you have to take the derivative and make it equal to 0. So I will do this next step, that I will make the derivative with respect to time and I will make it 0. Okay. So first of all, find out the derivative y of y dash t. I am calling this derivative equal to y dash t. So y dash t is how much? 2 by 3 difference, a constant term, the derivative will be 0. So now this minus 9 by 2 becomes 9 by 2 into e to the power minus t. Derivative I am taking this term. Now this will 8 into minus 2 is minus 16 into e to the minus 2t, and minus 25 by 6 into minus 6 will be positive. 3 2 cancel, so it will be 25 by 2 e to the power minus 3t. So this is the derivative of the system. Okay. Now what you do, you have to differentiate. After differentiation, you have to make it equal to 0. Why you have to make it 0? You have to find out the time instant. Okay. So what is the time instant? If you solve this in a, okay, if you solve this equation in a, like say I'm using a calculator. Okay. Write this equation in math mode. So go to math mode in your calculator. After writing this equation math mode, this t will be replaced by x. Okay, x is nothing but in the alpha option is there in the calculator. You just type down this x and then shift and plus solve. If you do these two buttons simultaneously, then it will give the values of time. So that time instant is nothing but 0.147676 one time, and another time equal to t2 should be 0.873975. These are the two time instant value you will get. Okay.
Sir,
Yes, ma'am. Yeah.
sir, could you please explain me the calculator operation one more time, sir? Math mode.
Okay,
Till
ma'am.
y dash of t, no doubt, sir.
Okay, ma'am.
I
You just
found
go
it.
to the
After
math.
that, calculate calculating part alone, you say it once, sir, in calculator by using calculator.
Okay, so go to the mode setup. If you are using a Casio calculator, then go to the mode setup. Okay, have you in the mode setup option?
Yes, yes.
In
Okay,
the
sir. Tell me, sir.
mode setup, otherwise you can write down if you don't have a calculator now. Go to the mode setup, then go to, because there are lots of
Okay.
option is there. One is this is computation, second is complex, then statistics, all this. So you place one.
Okay.
Okay,
Okay,
this
sir.
one is called going to the
Okay.
math mode. Okay, after going to the
Okay.
math
Okay,
mode,
sir.
directly write the equation. Let's say 9 by 2, 9 by 2 I can write 4.5. Okay, then
Okay. Okay.
4.5 into, you have to go to the exponential term. Okay, so exponential, you have to,
Okay,
what you
sir.
do, you have to just shift and the ln option, shift plus ln option will go to the exponential mode. Okay,
Yes, sir.
then you write minus,
Yes, sir. Yes, sir.
then you put e to the minus t na, so e to, after coming e, so you put minus, and then what you do, to write that variable t in calculator, t is not there, x is there. Okay, assume that t is x, so
Yes.
you press the
Okay.
alpha button. In the alpha button there is an option, you can see the curly, right curly bracket is x in the calculator, right
Okay, sir.
curly bracket. So press that x. Okay, so now you can see 4.5 e to the power minus x. Otherwise what you do, I'll on my video. Okay, I'll show you. Just have you calculator, or I'll show you when making my video on, and I'll show you. Do you have a calculator, ma'am?
Yes, sir. Yes, sir.
uh, Let me turn on my video. So this calculator I'm using, is the screen is visible? Is the calculator is visible, ma'am?
No, no, sir.
Is this calculator is visible?
Not,
No, it's not visible.
no, no, not visible, sir.
Uh, okay, ma'am. If the is not visible, then you just follow the instruction what I'm saying.
It's okay, sir. I understood. Yeah, yeah, yeah. I'm following, sir.
Okay. After writing this, you write the whole
I'll try,
equation,
sir.
ma'am.
I'll try.
Okay. After writing this, you just write the whole equation, and then what you do, there is a
Okay,
shift option, and after shift option, below the shift option, there is a solve option equal. Solve
okay.
is mentioned. Shift solve. So press shift and solve. Then you have to press
Solve option.
equal option.
Okay, sir.
Shift
Yes, sir.
solve
Yes,
and
sir.
equal. Then it will give you the directly the p
Okay, sir.
values. Otherwise
Yes,
means,
sure, sir. I'll
okay,
follow it, sir.
okay,
Yes, sir. Understood, sir. Thank you. Thank you, sir. Thank you so much.
okay, ma'am, no problem. Otherwise what you do, suppose you don't have a calculator, then what you do, how to solve this equation. I'm just telling the next slide. Let me write down here. Okay, suppose you don't have a calculator. Okay, and I'm writing out the equation. 9 by 2 e to the power minus t minus 16 e to the power minus 2t plus 25 by 2 e to the power minus 3t. This equal to 0. So what do you do? Take e to the power
25
minus t equal to
e
x.
to the
Okay.
power minus 4.
Take e to the minus t equal to x. So it will becomes minus 9 by 2x minus 16 into, this will be x square. Then it will be 25 by 2. It will be something e, x cube, right? Equal to 0, right, ma'am?
Yes, sir.
Then what you do, take x common everywhere, because if I take x common, this will be 9 by 2 minus 16x plus 25 by 2 x square equal to 0. Okay, so product of two number is 0, means either of them equal to 0. So here you get one value x equal to 0, other value is that this is a quadratic equation, 25 by 2 x square minus 16x plus 9 by 2 equal to 0. So from here you will get two values, x1 and x2, right, ma'am? Are you following me? So this is the second order equation. You will, if you solve this equation, you will get x1, x2, right?
I'm following, sir. By current method, we can solve.
Okay, okay.
Yes, sir. Yes, sir.
If you got x1, x2, then you can find out t
Yes, sir. Yes,
values.
sir. Yes, sir.
Right.
Understood, sir.
Okay. So,
Yes, sir. Thank you. Thank you.
but the question, what is the question is asking? Just listen carefully. So the question is saying, at what time does the through overshoot occurs in the step response? Now he see you have two values. You have now find out two values. So one is t1, other is t2. Okay. Now you know that after finding these two values, you know that overshoot. Overshoot means what? Overshoot means this value is overshoot. This is called a minima. Okay. Over sorry overshoot is something sorry overshoot means it is like this. Overshoot is a maximum point. Okay, undershooting is something you can get a minimum point. Okay, undershoot means minimum point. So so you know that how to get a minima point. So this question is related to mathematics completely. Find out the minima point because you have to find out the undershoot. So how you find out the minima of the point? So these two t values you have to put in the original equation. Okay. So what you do? These are the two values. Okay. So for to finding out the minimum and maxima, you have to find out the double derivative. Okay. So first this is y of t. This is y dash t. Now in that y dash t, you have to find out y double dash t. Okay. So what you need to find out? You go to a blank paper. So you need to find out y double dash t. And you know that in y, after finding out y double dash t, put that t value here. There are two t values here for t equal to t1 and y double dash t equal to t2. Now for minima, you know that this value should be greater than 0 and for maxima, this value should be less than 0. Means you have to put, this is the condition of minima. I am telling that y double dash t at that particular point, if it is greater than 0, then it is called a minima point. Minima means undershoot, and if it is less than 0, then that is a overshoot point. So but the question he is asking us to find out the undershoot point. Undershoot point means it is a minima point. Minima point means y double dash t has to be greater than equal to 0. Okay, so forget about this condition. So then put t equal to t1 and t equal to t2. So you see that at which point you are getting this y double dash t greater than equal to 0. Okay, so out of these 2 points, only one point will be there at which you will get y double dash greater than equal to 0. So that is called the undershoot point. Undershoot point exactly means this point you need to find out. This point. What is that point here? Okay. This point you need to find out. You are getting my point, ma'am?
Clear, sir. Understood, sir.
Okay. So, and if you put a t equal to, if you put a t equal to 0 0.8, okay, the second value 873975, then your y double dash t should be coming greater than equal to 0. Greater than equal to 0 means you are getting a minimum point. So, this value corresponding to this t, this point is that value. Okay. So this is the value at which you will get a undershoot point. Okay, now let us go to the next question, question number 4. So question number 4 also related to the previous question. You are getting that undershoot point, right, ma'am? Undershoot point means this t value, you know, at which you get the undershoot. So this is t value 0 0.8, okay, 7874. I'm just taking three values after decimal. Okay, because saying that two decimal point you check, so I'm taking 3. So this is the t value at which you're getting the undershoot. Now you have to say that find the magnitude of the system at that point. Magnitude means this value you have to find out. This is the magnitude, negative magnitude. Okay. So at this point, this undershoot magnitude you have to find out. So what you need to do, you have to find out your system y of t. Y of t is already, you know, you have already calculated y of t. So this is your y of t. So in that t value, y of t, because this is the equation of the line. So in this equation, if you put this t value, then you will get y of 0.874. Okay, 0.874 you will get. So that is the magnitude at this point. Right, ma'am? Are you getting? So just a undershoot means maximum
Sir,
minimum problem.
can you repeat it once, sir?
Means you got the already. the understood point, right? What is the understood point from the last question? 0.874, right?
Sir, T2. Yes, sir. Yes,
Yeah,
sir.
T2 you get 0.874.
0.874.
Now he's asking that find out the magnitude of the system
Yes,
response
sir.
at that time where the undershoot occurs. Okay, so if you know undershoot occurs at
Yes, sir.
0.874, then I have to find out the magnitude. So what is the magnitude? Magnitude means in the y of t equation. So because this is the equation of the line, so 2 by 3 minus 9 by 2 e to the minus t, this is the equation of the line. In that equation of the line, if I put t equal to that
Yes.
particular value, then I will get the magnitude at that point, right?
Okay, sir. Okay, sir. Understood.
Yeah. So put that t value in that equation y of t. So you can say y of t at t equal to 0.87. You put that value t here, you will get the magnitude. And that magnitude answer, if you want, the line can give, because it is negative. Na? Undershoot means a negative point, ma'am. So definitely this magnitude has to be negative. So that value should be minus 0.1208. This is the answer. It's clear?
Yes, sir.
Okay, let's go to the question number fifth. Okay, so the question number fifth also related to the first question. So he's asking that what is the steady state output to a unit step response, because already in that question unit step you are applying. After finding out y of t, I'm just writing down y of t. Y of t is nothing but 2 by 3 minus 9 by 2 e to the power minus t plus 8 into e to the power minus 2t minus 25 by 6 e to the power minus 3t. This is the y of t response, because this is the unit step response. So this is our unit step response y of t, and he is asking the steady state output. But in this equation, which part is the steady state part and which part is the transient part? You need to identify. But in the question, he is asking the steady state part. Okay. So what is the steady state value? So remember that in any, suppose, let me give an example. Let me give an example. Suppose your y of t is given 3 minus e to the power minus t. Then in this equation, can you tell me which part is transient part and which part is steady state part? Remember that steady state part will be if you put limit t tends to infinity. Okay, if in that equation y of t, if it tends to 0, then that is called a transient part. Okay, remember that if I put t tends to infinity, if I put infinity here, then t tends to infinity in this equation, and 3 minus e to the minus infinity, e to the minus infinity is nothing but 0. So all the exponential terms at t tends to infinity will goes to 0, right, ma'am? So transient means
Yes,
what?
sir. Yes, sir.
Transient means it has to die down after some time constant, right? Transient will not remain forever. Forever term is always a steady state part. So whichever term is there for infinite amount of time, that is the steady state part. So see, if you put t tends to infinity, this 9 by 2 e to the minus t tends to 0. This value going to 0. This value going to 0. So what is the part is remaining? 2 by 3 is remaining. So that is your steady state value, right?
Clear, sir.
Right. Let me see. Someone wants to join. Okay, fine. So you have to check what is the transient part if in this question. Suppose what is the transient part is for the unit step response. The transient part will be all the three value except 2 by 3. But transient part is that part. If I put t tends to infinity, that value going to 0. Means at infinity time that is dying out and it is equal to 0. So these three zero values are the transient terms, and this 2 by 3 term is the steady state term. Now coming to the question number 6. Okay. So question number 6 is related to the Bode plots. So what is saying that consider the asymptotic Bode magnitude plot shown in the figure below. Its transfer function is given by, okay, transfer function is given this equation. Now this is the Bode plot is shown. Now he is asking the first question, what is the value of A? What is the value of A? A means this value we need to find out. Next, seventh number question, what is the value of b and what is the value of k, is the eighth number question. So we need to find out this k value, we need to find out this a value, we need to find out this b value, means the pole zero location and the system gain we need to find out from this Bode plot. So how to do that? So remember, first of all, you just look at this Bode plot. This Bode plot, this initial slope is given. This is the initial slope which is starting. Okay, this initial slope is given minus 40 decibel per decade. Then this minus 40 decibel per decade becomes minus 20 decibel per decade after this corner frequency omega 1. Then from omega 1 to omega 2, this is a straight line. This is a one straight line having the same slope. Okay, the slope is same, minus 20 decibel per decade. Then at omega 2, this again minus 20 decibel per decade becomes minus 40 decibel per decade. So here there is a slope change. So at which point there is a slope changes? At omega 1 there is a change in slope. This is the change in slope. At omega 2 also there is a change in slope. There is a change in slope. So at omega 1, I am writing here, at omega 1, the slope is changing from minus 40 decibel per decade to minus 20 decibel per decade. Now you see, from minus 40 decibel, it is going to minus 20 decibel. So slope is changing from minus 40 to minus 20. It means what? Whether at this omega 1, there is an addition of 0 or there is an addition of pole. Are you following, ma'am?
Yes, sir. Following, sir.
So what is that? What is omega 1? It is a polar omega 1 is a 0. Your slope is
Both
changing from
answer.
minus 40 to minus 20.
Minus 20.
So slope is changing from minus 40 to minus 20. Decreasing slope. Huh? Slope is minus 40
Decreasing,
previously.
that means
Decreasing means
pole.
there is a 0 is added, ma'am. 0
Zero.
means what? 0 means positive, na? 0 means positive 20
Yes,
decibel
sir.
per decade.
Yes, sir. Yes, sir.
So minus 40 में हम
Oh,
for 20 add करेंगे तो it will becomes minus 20, right?
minus 20. Yes, sir.
So that addition number
Yes,
is
sir.
a
Yes, sir.
positive number, right? Positive
Plus
number
0.
means,
Top, top. Yes, yes.
yeah.
Yes,
So
yes.
at
Yes,
omega
sir.
1, there is a 0 is present. Just remember that at omega 1, there is a 0. Okay. Similarly, at omega 2, the omega 2 slope is minus 20. At omega 2, slope is changing from minus 20 to minus 40. So what is the addition of that minus 20 to minus 40 means? You are adding an
Minus
extra minus
20,
20.
minus 20.
Yeah. So
Yes,
minus,
sir.
so that it means at omega 2 there is a pole is there.
Pole, pole. Now understood, sir.
Okay, so now if understood, then you just write down the transfer function. Transfer function, transfer function is already given. Okay, so transfer function is already given, but we need to find out that value. So for that, we need to find out the omega 1 value and omega 2 value. Okay, so what you do in Bode plot, remember always that this concept is always applicable. What is that? Slope equal to, because slope is nothing but y by x. Okay, slope is nothing but y by x. Let me add some. After 1 hour wants to join. I don't know whether you can able to understand or not, but watch the video. Okay, the slope is nothing but, you remember slope is what? In any x, this is x axis, this is y axis. Slope is nothing but y, change in y divided by change in x. This is the definition of slope. Y
Yes.
equal to mx, so dy by dx is nothing but a slope. Okay, so slope is nothing but a change in y divided by change in x. So remember that. Okay, just I'm going to apply that concept here. Slope is nothing but change in y. Change in y means I'm calling this the magnitude axis. So magnitude, change in magnitude dm divided by change in x. Change in x is a log omega axis. Okay, this is a logarithm scale is given, so this should be log omega. It's the change in magnitude divided by change in logarithm frequency. This is the slope. Okay, Got it the definition how how I have written this slope. Slope is nothing but y by change in y divided by change in x. Change in y axis here is the magnitude. So I'm writing change in magnitude is dm and change in x is frequency. So this is a logarithmic scale. So log omega, right? Are you getting my point, ma'am?
Clear, sir.
Now you
Clear, sir.
see.
Clear.
Now you see. Now coming to here, you just see which slope I will take. I will take this slope from omega 1 to this value, this point 1. This is this line I will take now. Okay, in this line the slope is minus 20 decibel per decade, right?
Yes, sir.
So you just write down that the slope change is minus 20 decibel per decade. What is the change in magnitude in that axis in this line? This is a 1 point, you can say. This is 2 point. So what is the change in magnitude? So here the magnitude is 20 decibel and here the magnitude is 0 decibel, right?
Yes, sir.
So you can write down
So
change
plus,
in that. So final point minus
so
initial
plus
point. So
20.
final point is 0. Final point is 0. Initial point is 20. So 0 minus 20 divided by change in log omega. So final point is 2. 2 is the final point and starting point is 1. So change in x, so log 1 minus log omega 1. Right? Can I write like this?
Yes, sir.
Now from here, just find out what this minus 20 get cancelled. Okay, this will be 1. So here now, your log omega 1 equal to 1. If the log omega 1 equal to log 1, okay, log 1 is how much? 0. Okay, so omega 1 is something 10 to the power minus 1. Okay, are you getting my point? How I am solving this? Log 1 is 0, right? So minus log omega, this value is cancel out, means 1. So minus log omega 1 equal to 1. So omega 1 is 10 to the power minus 1. So 1 by 10. So omega 1 is 0.1. You just solve this equation, right? This simple equation. Are you following? How will you get omega 1?
Yes, sir.
Now
Got it.
similarly, you have to find out omega 2 and tell me what is the value of omega 2. What is the value of omega 2? Omega 2 is here, okay? Now this magnitude is known to you.
Yes,
This magnitude also known to you. You just take this slope,
sir.
okay? This slope you take. So you just write down the slope is how much? Again minus 20. Slope is again minus 20. And
Slope is equal
dm
to,
dm is what? Final value minus initial value. Final value is minus 20. Initial value is 0. So this is the final value, final, and this is the initial, okay? Because I'm considering this line, okay? Now, what is the change in x? Change in x is corresponding this point. This point is log omega 2
so
minus,
minus
and
two.
this point is log 1. Okay, are you getting? So omega 2 you will find out,
Yes,
omega 2 will you get 10. Are you getting my point? How will you find out omega 1 and omega 2?
yes, sir. Clear,
Okay,
sir.
after finding out what you do, this time I removing all this point. Just 1 second. So clarity. Okay. Now this is the question. Okay. Now in that question you already got omega 1 equal to 0.1, omega 2 is 10. Okay, so tell me omega 1 already you have discussed that this is a 0 and omega 2 is a pole. Okay, now you write the transfer function from this block diagram without looking at this. Don't look at this question, don't look at this. From the Bode plot you know that omega 1 is a 0, omega 2 is a pole. You already know the omega 1 value and omega 2 value. Now write the transfer function. The transfer function is k. Okay, so initial slope is minus 40. Is the initial slope is minus 40. See the initial slope, this initial slope is minus 40. Initial slope always gives the number of poles and zeros at origin. So it is minus 40 means it is minus 20 minus 20. So two poles are there at the origin. So because this minus number indicate that it is a pole and minus 40 corresponding to two number of poles. So k by s square is the first term because from the initial slope will gives the number of poles and zero at origin. It is a negative number, that's why it is a pole. And how many number of poles are there? Because minus 20, if it is minus 20 then
Two.
that corresponds to one pole. So multiplication minus 20 into 2, so two number of poles are there. So k by s square is the first term. Next, after the first term, at this corner frequency omega 1 you are adding a 0. So you add a 0, 0 means you have to add a numerator value. So that is called 1 plus, this is standard formula, 1 by s by omega 1. And again at 10 you have to add a pole. So 1 plus s by omega 2. So you know omega 1 is a 0 term is added and omega 2 is a pole is added. So this is the way you have to represent your Bode plot. This is in frequency domain because this is 1 plus st term. Okay, 1 plus s, time domain is t nothing but omega, so that's why it is 1 plus s by omega format. Okay, so always in time domain you have to represent in 1 plus st format, and omega domain you just replace this t equal to 1 by omega because frequency is nothing but inverse of the time constant. So that's why the representation is like that. Okay, so you put the value of omega 1 and omega 2. I'm putting k divided by s square. Okay, 1 plus s by omega 1 is 0.1 divided by, this is s square here. Okay, this is square, and 1 plus s by omega 2 is 10. Now you simplify it. If you simplify it, so before that you need to find out the k value. Okay, so how you find out the k value? Remember that whenever you're finding the k value, forget about all the zero and pole, means the forget about the finite pole and zero. Whatever the finite pole and zero, you just forget about that. So what you do, forget about means you don't consider that. Now your transfer function is now become simply k by s square. Okay, why? Because you need, you know, no need to consider, because this is the Bode plot is an asymptotic plot. In the asymptotic plot we have considered omega t value is always less than equal to 1. This is omega t value is less than 1, then this finite term will always equal to 1. So that's why we are not considering the final term in the calculation of our gain. Okay, so whenever you are calculating the system gain, remember that the finite term don't consider, only the consider the k value and the number of poles and zeros at the origin. So you see two number of poles at the origin, so you just consider the transfer function is like that. Now you have to write down the this magnitude of this. So if I write the magnitude of this transfer function, then definitely in the numerator k is there in the, so it will be 20 log k, and this a square when it is going to the numerator will be negative, so how much it will be? Minus 40. Okay, so 2 is there, that's why minus 40 log omega. Okay, so now this is the representation of this transfer function in the magnitude plot in decibel format. Okay, so 20 log k, why 20 log k? Because k is there in the numerator, so that's why the magnitude is 20 log k. And this a square ka magnitude is how much? S is nothing but j omega. J omega square means, so this is nothing but the omega square term. Okay, and the omega square when it is going to the numerator, 20 log, so 20 log omega square, so these two will be multiplied here in 20, so that's why it is 40. But it is going to the numerator, so that's why minus is coming. So minus 40 log omega. Okay, you're getting how I written this transfer function? Have you understood?
Yes, yes.
Okay.
Understood, sir. Understood, sir.
Okay, after writing out, this is the magnitude. Okay, this is the magnitude, but you see at which point you know the value. So after writing this magnitude, now this is the magnitude representation. Now you see this magnitude at which value you know the point. You see at omega 1 I know the magnitude is 20, right? So in this what you put at omega equal to omega 1, this magnitude is 20 is given from the plot. So put in place of omega you just put omega 1, and at omega 1 the magnitude will be 20. Now omega 1 you know omega 1 is 0.1, so replace that omega 1 is 0.1. I'm just replacing this value with 0.1. Now everything is known except the k value. Now solve this equation and find out the k value. So this k value is coming from 0.1. Okay, so this k value is 0.1. Are you getting how I calculated k value?
Yes, sir.
Now after finding out the k value, put the k value in the this equation. Okay, so I am replacing this k is now 0.1. Are you getting? Now simply
Yes, sir.
solve this transfer function. Now simply solve this transfer. Just solving means you have to express this transfer function in this format. Okay, s plus something, but it is not s plus something. It is 1 plus something. So just take the LCM and simplify it. So if you simplify it, then this transfer function is becomes 10 into s plus 0.1 divided by s square into s plus 10. So this is the, if you simplify it, you will get the transfer function is like that. But the original transfer function is given k into s plus a divided by this. So if you equate it to the original transfer function which is given in the question, original transfer function, the original transfer function is given k into s plus a divided by s square into s plus b, s square into s plus b. Now you just equate this first equation and second equation to find out the k value, a value and b value. So k value is nothing but 10, a value is 0.1, b value is 10. So these are the answers, 7, 8 and 6. So you'll simplify it and you'll get the answer. Are you getting my point?
Yes, sir.
Okay. Let's move to the next question. Question number 9. So question number 9 is given like that. So you see the transfer, see this is the input ROPS, this is the controller, this is the plant, this is the output YOPS, and there is a feedback. It's a negative feedback having a magnitude of 1 is given, a sensor. Okay, so GCS is given, this GCS whatever this value, it is given in the question, and this GPS plant transfer function is also given in the question. So what is saying, considering the pole zero cancellation, what is the closed loop system, whether the closed loop system is stable or it is marginally stable or it is unstable. So what do you do, first of all you find out the closed loop transfer function. So what is the closed loop transfer function? Closed loop transfer function is nothing but, I'm just simplifying this circuit. Okay, let me simplify this. GCS and GPS you get multiply, so if you multiply it, it will give GC and GP. In the forward transfer function, this is the loop transfer function, and there is a unity feedback having a magnitude of 1, and this is the given. This is y of s. This is y of s. Okay, and this value is nothing but a r of s. So if you simplify this block diagram, then you will get the simplified block diagram. Now this is the open loop transfer function is now, I'm just writing out the open loop transfer function is now GC into GP. Then what is the closed loop transfer function? Closed loop transfer function is nothing but GC into GP divided by 1 plus GC into GP. Okay, because if you consider this is a G, then this will be G divided by 1 plus G. Okay, like that. Because what is a unity feedback system is there, that's why. Because if the forward transfer function is g, then the closure transfer function is 1 divided g divided by 1 plus gh, and h is nothing but 1. Okay, that's why this is the, after finding out the polar transfer function and the closure transfer function, you first find out the closure transfer function. Closure transfer function is gc into gp divided by 1 plus gc into gp. So what is gc into gp? Gc into gp is given here. Gc is given to you 8 into s plus 5 divided by s into s minus 2. And what is gp? Gp is given 0.5 into s minus 2 divided by s plus 4. Now this s minus 2, s minus 2 get cancelled. So gc into gp is becomes, so this 0.5 is nothing but 1 by 2. Okay, this is 1 by 2. So this 2 and 8 is get cancelled, this will be 4. So 4 into s plus 5 divided by s into s plus 4. This is gc into gp. If you simplify, you'll get like that. Are you getting my point?
Yes, sir.
Now find out the closure transfer function. Gc into gp divided by 1 plus gc into gp. So find out the closed loop transfer function. Gc into gp divided by 1 plus gc into gp. So what is that value? If you find out that value, then you will get, I'm just writing down directly, 4 into s plus 5 divided by s square plus 8s plus 20. This is the closure transfer function. After finding out the closure transfer function, you see the characteristic equation. Characteristic equation nothing but this denominator term equal to 0. Okay, so s square plus 8s plus 20 equal to 0. If you simplify it, then you'll get s1 and s2 values. So s1 and s2 values will be s1 equal to minus 4 plus j2, and s2 equal to minus 4 minus j2. These are the two poles location. So definitely you can see that these two poles are lies on the left hand side. Okay, this is my left hand side because this minus 4 plus j2 is somewhere here, and minus 4 minus j2 somewhere here. So all the poles are lies on the left hand side. As all the poles are lies on the left hand side of a closure transfer function, then you can say the system is stable. Are you following?
Yes, sir.
Now the answer for this question is the system closure system is stable. Now coming to the 10th number question. What is the 10th number question? You just read it carefully. What if the system is internally stable or not? Okay, the system is internally stable or not? How do you verify that the system is internally stable or not? You see the plan. This is the block diagram is given. This is GCS and this is GPS. This is the plant transfer function. This is the input R of S. This is output Y of S, and there is a unity feedback is given 1. This is the system is given, but he is saying that whether the system is internally stable or not, what you do internally means you have to take an internal point. Let I'm assuming that this is my internal point, this is an internal point. Okay, so at this point you have to find out now the transfer function. Means now you consider this is your output y of s. I'm just shifting any other parameter. Let it is called let's it is called y1s 1. Okay, now you have to find out this is an internal point. So at that internal point you have to find out the transfer function. So y1 is divided by r of s. Now you have to find out because this is an internal point. So if you want to verify whether the system is internally stable or not, you take an internal point, consider that as y1, and find out the transfer function from this y1 as the output and r of s is the input, like you have done in the steady state error calculation. In the steady state error calculation, this is your G of S, okay? So this is your E of S, okay? So what you do is this is the summing point, this is your R of S, and this point is your H of S, okay? So sometimes you need to find out the transfer function from E of s by R of s, that is called the steady state error na? So this is the output Y of s. Okay, always no, don't consider that the transfer function is Y of s divided by R of s. This is the output transfer function. Any internal point means you have to find out E of s divided by R of s. Okay, so similarly here you have to find out any internal point. This is Y1s divided by R of s. So Y1s by R of s, how you find out the transfer function? This is the simple block diagram reduction. So from Y1s to R of s, this is only one forward path is there, and this is the forward path. Okay, if I start from this point, I'll reach the internal point through this forward path. So what is that forward path? GCS. Okay, and the loop transfer function is
Yes, sir.
always same. Remember that the denominator part is always same. This will be 1 plus GP into GC always. Okay, so that will not change. So it will be 1 plus GC into GP. So you simplify this block diagram. If you simplify this block diagram, then you will get 18, because GCS is known to you in the question it is given. GC into GP also given in the question. Just put that
18.
values and find out the value. This will be 8 into S plus 4 divided by S plus 5 divided by 1 plus GP. Into, to simplify it, you will get S minus 2 into S square plus 8S plus 20. Okay, now clearly you can see in the denominator this s minus 2, if you make it equal to 0, then s equal to 2, if this pole is lies on the right hand side, this pole is lies on the right hand side. If the pole is lies on the right hand side, the system is unstable. Okay, so system is unstable. So that's why the system is internally stable or not. It is answer is no. So it is false. Are you getting my point? How you check it?
Yes, sir.
Okay. So, like that, actually, you have to solve many questions. Some of the question related to Bode plot. Okay. So, you just go through some of the question and try to solve the assignment question. If you have any doubt, then you can consult me. Today, I'm stopping here. Okay. So, next class, we'll go to some state space analysis, I think, 11th. And so I'll take one extra class also. I'll let you the timing. Okay. For today, I'm stopping here. Uh, Thank you,
Thank you, sir.
everyone.
Thank you
Thank you.
so much.
Okay. Thank you, everyone, for joining.
Thank you, sir.
Okay. Thank you so much, all.
Thank you, sir.